we are pleased to announce the release of HyFive 2.0, an advanced, research-rooted screening and valuation tool developed by the GeoH2 team at UT Austin's Bureau of Economic Geology. This upgrade reflects your feedback and our continued effort to bridge geoscience, engineering, and economics in hydrogen storage evaluation. GeoH2 brings together industry leaders, academic experts, and stakeholders to tackle the complexities of hydrogen storage with a collaborative, data-driven approach. More on GeoH2 to visit geoh2.beg.utexas.edu. Welcome to HyFive, an innovative tool developed by the GeoH2 Consortium to advance the evaluation of geological hydrogen storage projects. HyFive offers a comprehensive platform that integrates three powerful tools: the screening tool, the cost tool, and the NPV tool. These tools are designed to streamline decision-making by providing clear and actionable insights into the feasibility and economics of hydrogen storage projects. The screening tool aims to identify key areas within the states of Texas, Oklahoma, New Mexico, Louisiana, and Mississippi, where various aspects of a potential hydrogen facility are most favorable based on market-related criteria. These criteria are broken down into 5 main categories: production and supply, transportation, demand, storage, and future projects. Each main category includes several subcategories that represent specific data points, such as the location of natural gas plants, wind farms, pipelines, cement plants, storage facilities, etc. The tool allows users to rank and prioritize these 5 main categories and their subcategories based on their preference for proximity to key infrastructure and resources they deem most or least important when identifying a potential hydrogen market. The tool's output is a comprehensive interactive heat map of these 5 U.S. states, displaying an overall hydrogen market suitability score, which encompasses the 5 main categories mentioned above. It highlights 10 key locations where a potential hydrogen market is most favorable, based on user rankings for each category. Each of these locations has a pop-up that describes the factors influencing its selection, making it stand out from the non-selected areas. Additionally, users can input their own latitude and longitude coordinates to compare how well their selected location aligns with their chosen rankings. The cost tool is a key feature of HyFive, designed to provide in-depth economic assessments of hydrogen storage projects. Step 1. Selecting the unit system. Start by choosing your preferred unit system, either SI or US customary units. This ensures that all inputs and outputs are consistent and standardized throughout your analysis. Step 2. Entering input variables. Now, let's input the key variables. Begin with the site information component, covering the basic parameters of the geological storage site. Then, we move to more detailed assumption components of major capital spending categories for the project. Here, first up is the drilling component. Each field has a default value already, while there is also a recommended range to guide user to set up their own scenario. For the solution mining component, which is relevant only for salt cavern storage, for the geometric volume of the cavern, you can choose to type in your assumption or use the option to use built-in algorithm to calculate the necessary geometric volume based on the working gas volume. Next, move on to the compression component, including inlet and outlet pressures. Last section covers assumptions of permitting costs and other land procurement and site construction of the project. HyFive allows the option of using NPV separately, allowing the user to enter their own CapEx costs or linked to the cost tool results from the previous section. If you'd like to incorporate NPV into your analysis, check the Use Cost Tool Input-Output box. NPV inputs include inflation rate, utilization, project start year, operating life, tax rates, discount rate, and debt-to-equity ratio of initial financing. Next, move to the commodity specification. The current NPV model can be used to model natural gas and hydrogen. Select commodity unit, initial price, and escalation value. Then, specify the installation cost, the number of months, the depreciation type, and the period if your installation costs are depreciable. Moving to capital expenditure, you can specify non-depreciable assets, the end-of-project sale of non-depreciable assets, whether non-depreciable capital assets are sellable, and working capital. If you have selected to use the cost tool, you can proceed to the next section. If not, please specify the capital expenditure values for drilling cost, compression cost, solution mining cost, and land, construction, and mineral rights costs. On the operational expenditure, we have labor cost, license and permitting cost, administrative expenses, maintenance, and fixed operational costs. If your project has any incentives, in the form of tax credit or cash, you can specify them in the incentives section. For variable operating expenses, specify the electricity, water, dehydration electricity, chemical, purification usage, unit, and cost, as well as escalation value. Once all inputs are entered, click on Find Results. Step 3. Calculating results, which are in 2 tabs, Cost Results and NPV Results. The tool processes the data and generates detailed cost breakdowns for each component of the project. The overall cost estimates of the project are presented in breakdown components. Then the output also includes additional analysis of each cost component. Drilling costs include steel costs for casing, rig and labor costs, and material and equipment expenses, covering fixed costs and variable costs. The compression cost simulates the power required for compression and the associated equipment costs based on the specified injection capacity and pressures. Solution mining cost includes the capital and operational costs for leaching and cavern development, along with costs for water injection and brine disposal. The last component covers land acquisition, storage rights, permitting, and site preparation costs. We also perform detailed sensitivity analysis on key model parameters. Next, moving to NPV Results tab. The tool demonstrates the project NPV, break-even price in million cubic feet and in kilograms, levelized cost, internal rate of return, investor payback period, profit index, and first-year positive earnings. Charts include the cash flow breakdown, levelized cost breakdown, investor cash flow, and Monte Carlo-based sensitivity of levelized cost. After reviewing the results, you can download these results for further analysis or to share with your team. In addition, you can load saved inputs and upload inputs from a CSV file and work accordingly. If you want to use default inputs, click on the box to reset the values. Thank you for joining us in exploring the HyFive tool. We hope this demo has shown how HyFive can empower your hydrogen storage projects with reliable, data-driven insights. If you'd like to learn more about HyFive and our GeoH2 Consortium, please contact us at hydrogenresearch@beg.utexas.edu.